clutter, right? Whatever the people have around this subject, AI will be very much clear to you, because I get a lot of questions and queries on my DMs that, hey, I want to start my career in AI. Should I learn the legacy machine learning, deep learning? Is it for me, or what should I go about? So I'll make that clutter clear. And all the tools that you see around you, right? There are, hundreds, thousands of tools, AI tools right now, will all be drilled down to just three applications of the data, right? So that again, I'll introduce you one more analogy so that every one of you are on the same page regarding this whole industry. Okay, so I'll give you one more example here. Like, let's say I want to convey some information to you, and if I tell you there are only three ways through which a human can communicate on this planet, right? There are only three ways. So, for example, let's say I want to give you the information that there is 50% of sales going on. Let's say Independence Day sales is going on Adidas, right? So, this information I want to convey to you. Imagine I'm sending you a WhatsApp voice note where I'm telling you the voice message that there is a 50% off on Adidas. You got this information. Second, I can send you a text message, 50% off on Adidas. You got the same information. And I can send you image where the 50% off is written, and you got the same information, right? And there is no other way how human communicates on this planet, right? Or how can I give some information to anyone in this, other side of the world, either of these three ways, right? So that is why it became an important, you can say, subject, which is a deep learning, which has the whole neural network, or you can say artificial neural network architecture, where we were dealing with images, text, and audio, right? All of that, audio files, text files, and I want to extract the information and give it to the company or user, right? And whereas machine learning was mostly working on the structured side, where the job is to get the data or patterns out of it. So, for example, a very simple example I can give you is your Gmail inbox, right? Every email has to be classified whether it should go to your inbox or it should go to your spam box, right? If it is having some lottery tickets and all. So all of that was happening, right? It was already there from last 10 years. People were building all the applications which we are using right now also, right? So all was there. There was nothing new that AI has made a new model kind of a thing. It was already happening, right? But challenge was, right? Or I would say the caveat was, it was only for techies, people who know programming languages like Python, people who know about these subject frameworks like TensorFlow, PyTorch. They are the only ones who are building these applications, right? But when ChatGPT came in November 2022, right, like first time the large language model concept came out, it has opened the gates for everyone. Now, irrespective of whether you know Python or not, right, you can build AI applications, you can solve problem, right? You just have to write an instruction and get the output. I don't have to go back and code for a simple sentiment classifier that I have an Amazon reviews and I want to classify it positive, negative, and I have to go and build the model. I can simply type in, can you classify each and every review into positive and negative? And that's the shift, right? And that is why you are seeing plethora of AI application coming in, right? And all of these applications, right, now you think it of, any application will fall under these three buckets only. It will either be into the text space, right? All your chat GPT, all your this Claude, this Perplexity, right? It can generate text, it can generate images also nowadays, right? ChatGPT can generate images, but via different model. So it can be either text, it can be either images like Midjourney, or it can be either audio, right? Or combination of all these three, right? Audio, we have a very famous app called 11 Labs, right? Which is only focusing on the audio side of it. So now every tool is just a permutation and combination of my these three data points which we generate, right? And if you are thinking where are the videos, videos is nothing but your images only, right? So don't think that videos has a separate category. The answer is videos is nothing but your multiple images being rendered in 1 second. That is how we have the terms called FPS, which is frames per second, right? You might have heard about 30 FPS, 60 FPS. While you record a video from your phone, you get those settings, right? So that is nothing but your image is rendered in a 1 second, right? So now we are on this subset called large language model. Now the name decodes that it is larger in size. It is only dealing with language application, right? All the language stuff, all the information regarding, let's say, all the languages across the world, right? It has been fed to the model. And that's how the term coined large language models, which has only focuses on the language related task, no images, nothing. So a lot of people get confused when I say, okay, can you tell me which model is mid journey, right? So they say LLM. No, the images generation is a totally different model, which is known as diffusion model. But this is only large language model, which is only related to language stuff. And now we will be decoding this model, that how does we get an output when we ask something on, let's say, chat gpt, right? So let's break down, right? It is really important because we are building and we are using these tools on the daily basis. And if we know the back end of these tools, how they actually work, you will be getting a better response, right? And that I'll show you right now, because we have the 5 step process, that what happens when I input something on chat gpt and I get a magical output back, right? So how does it happen? Let's do it practically. And that's the first learning that we'll be having, how these model behave or how they actually work at the back end. Okay, so if I go about and ask what or can you explain me LLM? Can you explain me about LLM? Right, very simple query. If I go and type this, the model will go back, get me the right answer regarding the large language model, right? And it is a completely technical definition. What I have got, right? You can see it is based on the transformer architecture. It has something called tokens, right? Which we will be covering right now in our next step. But if you carefully look at the response that I have got, is completely technical, right? So for I'm assuming like any person in this call or a group of people who are into marketing, who are into, let's say, sales, might not be knowing all these terms, right? And that is what I have done exactly, just to show you the difference once we'll reach on the step. But I got the answer, which is very much technical, and it is showing me some of the application and steps that are involved. Perfect, right? So now we will be looking at how does model gave me this answer if I ask something onto that window, right? So that is the 5 step process, and we will discuss all the five, right? And hardly I would say 4 steps are really important. Fifth one is automatically derived. So just focus and ask 2 questions on each and every slide, why we need to do that and how does it happen, right? I'll make sure I'll clear all these 2 questions, but you should have in your notebook why and how of these steps. Perfect, right? So now let's discuss about the step one, which is known as tokenization, right? As the name suggests, breakdown of my text into smaller tokens. Now, these tokens are nothing but my words, right? So if I am writing something onto the chat GPT window, it will take each and every word as my single token, right? Just a rule of thumb. It has some mapping, right? Like 4 tokens is are about 75 characters and all. I mean, 100 tokens is about 75 characters and all. But you just imagine how many words I have in my input sentence will be my each and every token, right? So for example, if I type in explain large language models, each and every single word is my token, and that's the breaking down of my entire sentence into these tokens. How it happens visually, let me show you practically. And I'll ask you one question on this slide particularly once I'll explain you, so that you get the complete understanding, right? So let me show you practically about this. Okay, so here I am typing, hi, we all are learning Gen AI today, right? So my sentence is, hi, we all are learning Gen AI today. I have 8 tokens, right? 8 tokens has been utilized, or you can say 8 words. But if I tell you the model is not looking at your English sentence, right? Model is not at all looking at your English sentence. For the model, right? Let's go back into our high school when we learned that the language of computers is binary, right? Numbers. Computer understand numbers. All your keyboard as well, right? Whatever you type in your Word application or you type through your keyboard has some numerical character associated with that, right? Number, ASCII values. So it's a basic thing that computer understand numbers, right? So if I tell you model is looking at this sequence of numbers, right? And how it is getting mapped, now I have a question for you. Do I have a finite set of words in English language or I have infinite words? Can you give me a quick response in the chat? Do I have finite set of words or infinite? Okay, some are saying finite and few are saying infinite as well, but mostly it's finite. People are giving the correct response, absolutely correct, right? So it's a finite set of words, right? Imagine yourself, you have an English Oxford dictionary, right, that we used to have in our childhood, when there was no digital penetration at that time, right? I am from that generation, right? So I had that thick Oxford dictionary onto our study tables, and it has all the words from A to Z, right? So it's a finite set, right? It's not an infinite, it's a finite set. And if I just Google search it, there are about 1,30,000 words, right? 130K words are there in the English language, right? We are only talking about English language. And out of that 130K, we as a humans read and write around 30 to 40K vocabulary words, right? Unless and until we are Shashi Tharoor. So we don't use the hi-fi language in our day-to-day responses. So we use around 30 to 40K words. And that is the I mean, Google statistics, which is coming from. So you can just find it on Google. Right. So now if I have an infinite set, and that is again, let's say 1,30,000 words, I can still assign a one unique number to each and every, you can say, word, right? And all my sentences throughout on the internet, all my articles, all my web pages, you imagine every data which is present in text is the permutation and combination of my these words only, right? So that is where model needs to break down my entire thing into single tokens, right? All my words is known as tokens here, which is known as the tokenization, right? That's the first step. So model will break down my input into tokens and bring all the numeric token IDs what it has, right? That's the first step. And why it has to do? Because all my costing is also associated, right? We don't know about the costing much on the front end applications, which is Chat GPT and other tools. But when you go and build your own applications using something called APIs, which you will be learning, by the way, in your next sessions, I think tomorrow's session or maybe today's session, you have that API concept also coming in. So when you build your own applications, you need or your cost is associated with all these tokens, right? How many tokens you're utilizing. So model needs to take care of that. Okay. So that's my first step. We are clear that why we need to do and how it happens. We have already seen that. Second step is my very, very important, which is known as embeddings, whose job is to convert now these tokens into numerical vector so that my meaning of these words get introduced into my model, right? So in my first step there was just a concept of breaking down of my words into tokens. The job of my embedding model, right, it is also a model, by the way, right? So we don't know because we use the front end application, but at the back end, right, at the back end of Chat GPT, there is an embedding model whose job is to bring the meaning of my ask into the picture, right? Whatever I have asked on Chat GPT, it will try to bring a numerical vector associated with that word, right? So like if we have given an input, explain me about large language model, it will bring the numerical vector for explain, the word me, the large language model, all of that meaning is coming into the picture via this model, right? Again, I'll show you visually so that you have the you have some image in your mind, right? And you can remember from it that how the embeddings actually work. And I'll give you two sentence. You will be very much clear about this, right? So these are all my words in English language, right? They have, I mean, just 10,000, they have filtered it out. So these are my 10,000 words which are plotted in three dimensions. Now, right, I can see all the words which are, I'm just hovering my mouse. I'll give you two sentences and you will understand this whole embedding process. So, my sentence one is, I am eating a delicious apple. And second sentence is, I am using an Apple iPhone, right? How does model understood about which Apple I am talking about, right? Because it has learned all the context from the internet, right? So it knows that there is an Apple fruit and there is an Apple brand, right? Why? Because there are certain words which are only associated with my apple as a fruit, and certain words are only associated with the apple as a brand, right? For example, stock price of apple. So if I'm asking stock price of Apple, if I just Google search this, all the articles, now it will come, right? Let's say top 10 articles. Just thinking, right? Just think logically that if I just Google search right now, stock price of Apple, and whatever top 10 links I'll get from Google will only be associated with the brand Apple, right? It will only with the brand Apple. And if I type this query, uh, how many calories I have in Apple, right? It will always be, right? All the 10, 20 links of my starting page, the word calorie, I mean, it can associate it with an Apple Watch also, right? But if I'm asking how many calories are in Apple, that means the user is talking about a fruit apple, right? So model can distinguish those patterns. And if you can see, right, near words, Macintosh, Windows, Mac, Intel, all these my words are near, or you can say are used alongside with Apple, right? And that is why the job of embedding model is to bring the clear cut meaning into my picture, right? So those two steps are done: tokenization, embedding. Third step, really again very important, right? Self attention. As model says, I mean, as the definition says, the model focuses on only important part in my text, right? Or I would say model give more weightage to some part of my input sentence so that it knows what the user is actually asking, and it happens automatically, right? Again, I'll show you with the example so that we have the entire representation how it actually works, right? So the third step is self attention, which automatically focuses on which part of my input I should focus on based on the user query, right? So now I asked, like in my first response, I asked this thing, can you explain me about LLM? And it has given me a technical definition. I'll copy this exact same sentence. I'll go to a new window, right? I'll just paste it. Explain me about LLM as if I am 5 year old, right? So if you see that I have just added this particular line, right? But now my response will totally be changed, right? It will be changed totally. And model itself focuses on this part, that I have to give the definition of LLM, but not a technical one, as if I have to explain it to a 5 year old kid, right? And that's the beauty of self attention, which give more weightage to some part of my input automatically, right? It's all mathematics at the back end, right? I'm not going into the mathematics. We have a lot of transformer architecture science going behind. We have key value vector, query vector, value kqv vector, multiplications going on. So that's a whole technical stuff. But if you understand logically what is happening, it is giving more importance to some words in my input sentence. And now if you see the definition, imagine you have a super big boy box, a big toy box inside the millions and millions of toys, so many no one could count them all, right? All of this is coming. That's what an LLM is. So now if I go and explain it to an 5 year old kid, he or she will be able to understand this definition, right? So that is what is happening in my self attention part. And now the fourth step is how the model is giving me the output, right? So the first three steps, tokenization, embedding, and self-attention, belongs to my input part, right? Whatever we ask on ChatGPT, those three steps are contributed towards my ask. The next step, fourth step, right? We have only 5 steps. We are on fourth step right now. It is on the output side, right? Models start giving me the output. And this is very, very simple to understand. I'll start with the example and then explain you how the science behind this step is working, right? So you give me the response now, that if I have this sentence, Imagine you have a super smart robot friend who has read every dash. What all words can fit in this dash, right? One possible word is book. Can you give me few other words in the chat apart from book and bank? What all can fit, right? Blogs, yes. Article, mind, newspaper, novel, journal, poem, website, magazine. Perfect, right? Journal, books. Perfect, right? I think you got a great understanding of this step, what I wanted to have this exercise to be done. So now go back, right? Go back to your thinking what exactly you have done, right? How did you perform this exercise, right? Same way AI also does. So what you did, you went back into your brain and thought, what can be the possible words that I can fit in here, right? That I can predict in here. And you gave me newspaper, magazine, poem, journal, all these words which can fit in this sentence you gave me as an output, right? So that's what model does. Same, right? Model has limited, right? We have finite set of words. We all know now it's a finite set. Model assigns a probability to each and every word. So that's the job of model, that it assigns the probability between 0 to 1, right? We all know probability. It's a mathematical, I mean, very beautiful subject, I would say, right? So it's a mathematical model which is giving the probability output. So it assigns each and every word a probability, and now model picks it up from those high probability words, right? So maybe book is having a probability of zero point 0.6, right? Newspaper is having a probability of, let's say, zero point 0.4. But have you given me any other word which doesn't fit in this context? Let's say the word, let's say democratic, right? Imagine you have a super smart robot friend who has read every democratic, right? It doesn't make sense. So the probability of word democratic will be 0.001. Or let's say table, right? I'm having my laptop in on top of table, so I got this word table, right? The probability of word table will be 0.0001. Why? Because it doesn't make sense. Who has read every table, right? No sense. That is how the model assigns the probability, and it keeps on predicting the next word that can be fit in unless and until I get my response back. Right? All my response get back. So it predicts one word at a time, or now I would say one token at a time, and it keeps on doing until and unless I get my entire response generated. And this is how the LLM works at the back end, right? So all my steps, you can take a screenshot, by the way, right? I mean, that's totally fine. But it is the 5 step process, starts from tokenization, getting or breaking down all my words into tokens. Second step introduces meaning into the picture, right? It introduces the meaning for all the words that I have been using in my input sentence. So the job of this step is to bring the numerical vector or meaning into my picture. Third transformer mechanism is the self attention, which gives importance to the relevant part. Finally, the output start getting out from these model, which is a nothing but your probability, right? So it's all probability, which is assigning your words some probability, right? And picks from the top words. And finally it is I mean, it is repetitively, iteratively happens until and unless I get my full response back. Now one more thing, right? You might have this question that every time I ask chat gpt I get a different response, and now you know why that happens, because of my prediction step, right? I'm not saying it always give you highest probability word, right? If you are focusing on my words, I have used higher probability words, right? It's a set of words, 10, 20, maybe 50 words, right? Out of 1,30,000, what are my top 50 words? It is choosing from those top 50. If I say that it will always pick up highest probability word, then ideally I should get all my response same every time I input the same query, right? Because it's a mathematics, there is no smartness. If I ask the same question again, like let me show you practically, I should have got the same response, but it doesn't happen like that, right? It's a by choice, or you can say by design. We have made, there is some settings of like parameters which we control at the back end when we train these models, right? I mean, you don't have to go because you haven't, or you are not building these models, but there is a setting called temperature which we use to control, and by default it is set to, let's say, 1 here, which is creative responses, right? I'll not get the same response. but it will be similar response, which is in the context of what you are asking, right? If you compare it, I am not getting the same response, I am getting a different one. That this is one, the earlier one, and this is my same input, but I got a different response from my previous one, right? So that is how it works, all my 5 step process. And i hope I hope you all of you understood how the Gen AI works. A quick check on the chat.